All right, here's another one from the same worksheet. It's this problem right here. A soda can holds 354 cubic centimeters. Its top and bottom are twice the thickness of the side. Find the radius and height of a can that minimizes the material used. So minimizes implies to me that there's going to be a graph where there's some minimum. We'll take the derivative and find where that is. So calculus once again. Let's start with, what do we know? The area, the surface area of a cylinder, you have to look it up, is this, and 2 pi r squared, where this is like the surface of the sides of the can, and then this, notice this r squared, this is the portion on top of the can. In other words, that part. This part right here is the sides, like the roll that would go around it, and this part is the, where we have the pi r squared, the circle part. So since it's twice the thickness, we're gonna double that. We also know that the volume is pi r squared h, which is actually equal to 354. And so I can set that up right away. And what we want to do is solve for h. So if I divide both sides by pi r squared, we can get rid of this and have h equals 354 pi r squared. Take this now and plug it into that, and we'll be able to work from there. So area equals 2 pi r, and now let's put h in, pi r squared, plus, now let's go ahead and multiply this to make 4 pi r squared. Don't necessarily need the parentheses. I'll get rid of that in the next step. But let's keep this set up. Okay, so now I'm going to multiply the 2 times this, and essentially I could cancel out these pi's, and then one of these r's could go away. So I'll scratch out the r squared and scratch out the pi, and it'll be 2 times this, and then we got that. So 2 times 354 is 708 over r plus 4 pi r squared. And we're about to do the derivative, so I'm going to move this r up. I'm just going to rewrite it so that it's 708 r to the -1, because as you know, when you change levels, you get an exponent turns negative. So now we have this, and we're ready to differentiate. We're ready to do the derivative. This power is going to come down, so it'll make a -708, and we'll write a prime equals -708, and then that becomes -1, so that'd be -2, and then this comes down, makes an 8 pi r, and then we reduce it by 1, so there you go. Now let's move this back underneath. So a prime is equal to -708 over r squared plus 8 pi r. So now, once we have our derivative, we need to set it equal to 0, because that's the slope. The derivative always gives you the slope of the tangent line at a given point. So since the slope is equal to 0 at any maximum or minimum, we can just do that right here. Set it equal to 0, r squared plus 8 pi r. And now I'm going to subtract 708 over r squared from both sides, which puts that over here. I'm starting to run out of room. Pi r equals 8 pi r. All right, now we want to solve for r, so I'm basically going to put, I guess you could more elaborately say r squared over 1, r squared over 1, multiplied times both sides. That would cancel these, and then it would end up over there. So we got 708 equals 8 pi r cubed And if we divide both sides by 8 pi, now this is gone. We're getting closer to what r is equal to. So let me just rewrite it. While I'm at it, might as well do 708 divided by 8, which is 88.5, I believe. Yeah, 88.5 over pi equals r cubed. So if we take the cube root of both sides, then we'll have this. And this is essentially a decimal. If you take 88.5 divided by pi and then do the cube root of it, you'll end up with approximately 304 equals r. So there's our r value, and we can plug that back in up here to solve for h. So I'm going to borrow this original 354. 354 equals, and it used to say pi r squared h. So I'm going to plug in 304 for r, and we'll have pi 3.04 squared h. 354 equals that. If you do 304 squared and multiply it times pi, what do we end up with for that? I don't have access to my calculator right now, but 304 squared times pi. I guess I can move this. I'll just divide both sides by pi times 3.04 squared, pi 3.04 squared. So now this is gone, and h equals what this mathematically boils down to, which is, where's my answer? 12.17. If we square this, multiply it times pi, take that divided by that, you end up with 12.17 for h. So now we know to minimize the materials in the can, we need our h value to be this and our r value to be that. And that's kind of the magic of calculus, is that you can actually solve these complex problems if you understand the nature of how to use the derivative. So there you go. Okay, so just supplemental info on that problem we just did by using Desmos. Go in here and let's take that first equation that we created and plug it in, just see what it shows us, because it tells us a lot. 708 divided by r squared. Wait a minute, r to the negative 1. Okay, so that means just over. I'm using x instead of r. So now we say plus 4 pi r squared. So I'm using x squared. All right, so we got 708 over x plus 4 pi x squared. Let's zoom out and take a look at what the graph is showing us. I'm going to stretch it horizontally so we can actually see what's going on. And here is our minimum. If you touch right there, it'll show you the point, and you can see 3.04, just like our math told us. And so there you go. You can actually find the value just by looking at the graph. But if we go a little further and actually show what the derivative gave us, which is negative 708 divided by r squared, I'm using x again, plus 8 pi r, or x I should say, then touch that point and you can see it's also only think about the difference here. The red curve is the original function, but the blue curve is the derivative, which gives you the height of that function. The blue function is telling you the slope of the tangent line. So like on this, if I cruise along the curve, it shows you you'd have to imagine a tangent line, and when it gets to here, it actually flattens out. And that's what this point down here is actually telling you, that the height of the blue line is the slope of the tangent line on the red curve. So where it crosses the x-axis and basically equals 0, the height equals 0, is that point. And so anyways, they're both in agreement here. And there you go. So you just take that value and plug it in to find your h.